right, what I need you guys to do is draw a triangle on your paper. You've got a ruler, and I want two of your sides to be 5 centimeters and 7 centimeters. The third side can be whatever you want it to be. So 5 centimeters, 7 centimeters, and then make the third side whatever you want it to be.
Wait, in the middle of the paper?
Near the top. I would put section 4.2 near the top so you know what the notes are. Draw one side of 5, one side of 7. So let me get my ruler out and I can show you how it might look. You can make your third side whatever length you want it to be. So if I was doing it, I might make a 7. 70 millimeters would be 7 centimeters. And then I might turn my ruler up like this. And then draw in 5. So I would have a 7 centimeters on the bottom. Now you can draw it any way you want. You can make the angle any way you want. I would prefer maybe even you make it different than mine because you want to. I want you to see that the concept that we're going to show you today works for every triangle. So making yours a different shape than mine would be a good thing, not a bad thing. Okay, so whatever you want it to do. But then what I need you to do after you've drawn your two sides is to connect those and measure that and see what the measurement of that side would be. It's always hard to do it on this screen here, but I'm going to do that about there. And just put in your last side. And then get an exact measurement. Might be like a decimal, like mine is 6.2. Looks like about 6.2. Okay, the next thing I want you to do is take your protractor and measure all 3 angles. So grab your protractor. And all you really have to do is measure 2 of them, because what do we know about all 3 in a triangle? They add up to 180. So if you measure 2 of them, and then you subtract that from 180, you'll have the third one. So you could just simply find the measure of 2 of them. Now for me, this first one is 59 degrees. So put that measure in there. Put your measure. Yours should be different than mine. I'm going to measure the other bottom one. And mine's about 43. So if I was to take the 59 and add it to 43, if I was to add that together, I would end up with 102 degrees. So rather than measure my third side, I can just take that 180 and subtract 102 from it. And that's going to give me about 78 degrees. So for me, my third angle is going to be 78 degrees. So that's one way to find the third one. You could have measured the third one, and you could always double check yourself too. You could do the math calculating and then use the protractor and verify that your math was correct, or verify that you did the protractor correct and you know how to use the protractor. So get your 3 sides and get your 3 angles. Just hit the red button. All right, so let's take a look at the triangle that I have on the board. Okay, then we'll come back to yours on your paper. So on the board, I'm going to label an A. So you might want to put an A on yours. I'm going to put a B and a C. Now on the board, if you notice that I have my biggest angle. My biggest angle is which angle? Is B. Everybody see on the board, the front board, my biggest angle is B? Jude, you see that?
Yeah.
Why is that the biggest angle? There is a reason. There is a reason that that one is the biggest angle. Because the 5 and the 7? What about the 5 and the 7? There is a reason that that B is the biggest angle out of the 3. And it has to do with when you open it up. When you're opening up an angle, there's a side across from it, isn't there? If you open it, if you've got a little side and you're going to open it up a little bit, right? If you've got a big side, you're going to open it up a big amount. So why would 78 angle B have to be my biggest angle? What is it opening up to? What is 7 in comparison to my 3 sides? Is it the smallest of the 3? It's the longest of the 3. So if you notice on your paper, look at your paper, find your biggest angle. Look straight across from it. That should be your biggest side. Should be that way on every single triangle, ever. Your biggest angle. So if I was to show you an arrow here, if I can get it to work. My biggest angle here would be across from my longest side. Longest side because 78 degrees is my biggest angle. Okay, so and that should be the same on your triangle. If you find and locate your biggest angle, you should look across from it and it should be opening up to your biggest side. That should happen on everybody's triangle. Check it, make sure it does. Now, why is angle C my shortest side? Why is angle C the shortest? If the longest side is across from the biggest angle, my smallest angle has to be across from the shortest side. So I'm going to look right here. This 43 degrees, you look straight across, and that's going to be my smallest side, or I'm going to put shortest side, because 43 degrees is my smallest angle. So the shortest side was side AB because it's across from the smallest angle. Let's make those a different color so you can kind of see the difference of them. So the shortest side was AB, which was 5, because the angle was the smallest, 43. If you're only opening up to a 43 amount, then you're only opening up to a smaller amount. If you're opening up to a big amount, like 78 degrees is bigger, it's going to open up to a bigger side. So bigger sides are always across from the biggest angle. Smaller sides are always across from the smallest angle. That's one concept that works in every triangle. You should see it in all your triangles out there. That's actually a theorem that we use. So we just proved it by showing that we measured all the angles. And it should have worked in every triangle out here, so that works. There is another theorem that we want to talk about. Another inequality in triangle that we want to talk about. So I'm going to get some of your third sides. My third side was 6.2. So let me write that one down first. Okay, so let me hear some of your other third sides. What'd you get?
56.
56 as the third side?
Wait.
No, the third side, not the angle. 5.7 I heard. Okay, give me another one. 10.6, 6.3. What was the other one? 7.5. Oops, 7.5. What else? 9.5. Anything smaller than 5.7?
I had 5.1.
5.1? Anything get smaller than 5.1? Anybody getting the 4s or 3s or 2s or 1s or anything? No? Yes? How much? 3.6? Okay, anybody get higher than 10.6? Any 11s or 12s or 13s or anything? Okay, so let's just say then, what would be a good estimate for our range of numbers here?
I would feel like 11.
So it looks like its smallest one was 3.6. Our biggest one was 10.6.
What about 8.8?
So anybody get 8.8? You got 8.8? No? 8.8 could work probably. 8 point what? 8.5, okay. We'll put that one down because that's right in the middle. Okay, so if you notice, all of those numbers that I just showed you, they're all between 3.6 and 10.6. So do you think that we could have any number smaller than 3.6? Could we have drawn a triangle where 3.6, or where the third side was smaller than 3.6? Let me show you a triangle here. Okay, see a triangle. Let me make it so it's got like a 5 here. We'll call this side the 5 and the 7. Okay, so it'd be something like that, right? Or no, 5. So if this side's a 7 right here, then this will probably be about a 5 here. Could this smaller side be less than 3.6? If I made this really small, I'll move it up. Oops, I'll move it up here so you can see it. Okay, see this? You see if I make the angle, this is my 7 on the bottom, this is my 5. If I make the angle really, really small, could we make that smaller than 3.6?
Yeah.
What do you think we could make it?
I would like
Could we make it a 1?
I would say like
Yeah.
1.2.
So you think we could get that small enough to make it a 1? So you'd have a 5, you'd have a 7, and you'd have a 1? You think we could do that?
Probably.
What happens if I got a 7 right here, right? What if I laid the 5 right on top of the 7?
There's nothing.
Then what would be left over? 2. 2 would be left over. So if my smallest side's a 2, could I even make it a triangle? No, because the 7 and the 5 and the 2 would be right on top of each other. You'd have a line. See the line right there? Is that a triangle? No. So what does that tell me about this little side if I make it into a triangle? It can't be smaller than 2. It can't even be 2. It has to be larger than 2. Okay, so that's got to be bigger. Now, what would happen if I went the other way? What if I was to take my triangle and I have my 7 and my 5, and I made it as big as I could. Still trying to keep it a triangle though. What if I made it a straight line? Here I've got my 7, here I've got my 5. What would the whole other side have to be then? 12, but could it be 12? No, because the 5 and the 7, you'd have a line right on top of the 12. So this third side greater. So look at it again. Here's 12, right? when I make it a triangle, I've got to actually make that a little smaller.
Oh, yeah.
You can't be more than 12. It'll be too long. It'll overextend the other two sides. So it's got to be less than 12. So here is the inequality that we would want to write down. Okay, let me make it a little bigger here so you can see it. But your smallest number could be 2, and your largest number could be 12. X, which is the third side, has to fall somewhere in between those. So the X, let me move this triangle. Put it right here. The X, our third side, must be between the 2 and the 12. So our third side, now mine was 6.2, so did that work?
Yeah.
Yes, 6 would work. Would 12 work? 12 would not work because it's not less than 12. Would 15 work? No, but would 8 work?
Yeah.
3?
Yeah.
7?
Yeah.
Yes, any of those numbers that are between 2 and 12 could be a third side. Anything that's outside of those two numbers can't be a third side. It would be, it would not make a triangle. So the shortest side is across from the smallest angle. The largest side is across from the largest angle. Then in all of our triangles, the third side has to be somewhere between. How did I get 2 and 12?
You got 2
How did I get the 2 with the 5 and the 7? You subtracted them. So this little 2 right here, I'm going to make this small here. This 2 I got by doing 7 minus 5. That's how I got this 2 right here. How did I get the 12? 7 plus 5. So how did I get my two numbers? Well, I added and I subtracted the two sides. Your third side has to be between those two numbers. So when you add and subtract the two sides, your third side will be always in the middle. Now test that on your triangles. See if that works. Is your number for your third side somewhere between the 2 and the 12? It should be. Your number should be somewhere between 2 and 12. And when we wrote down our third sides, it did work. All right, let me show you the next slide. The next slide, you don't have to write much down because you probably just did. Okay, if you wrote what I put in purple here, then you made it a lot easier on yourself because the theorems are longer. I just wanted you to see them though. Here's a triangle with 7, 16, and 22. Who can tell me the biggest angle? B. Why is B the biggest angle? Because it looks the biggest? No, because it's across from the biggest or longest side. Yes. What angle is the smallest? C, because it's across from the smallest or shortest side. Okay, that's what the theorem says. You can look at it. Like I said, if you wrote down what I had on the previous slide, probably don't have to write it here, but it says if one side of a triangle is longer than another side, then the angle opposite the longer side is going to be larger than the angle opposite the shorter side. A lot more wordy here. I wrote it a lot smaller here. Longest side because 78 degrees is my biggest angle. So you might want to put something like, just really quick note to yourself. Make it a little bigger. Longest side always across from biggest angle. So you might want to just write yourself a little note, maybe a star there that shows that. Longest side is always going to be across from your biggest angle. Same thing with shortest side will always be across from the shortest angle. So that when you look at the theorem, it's a lot more wordy. You don't have to write the whole theorem down. You already know what the theorem is saying. What this theorem says right here is that the longest side is across from the longest angle. That's all this is saying. The second one is saying the exact same thing, except they're changing the angle on the side. They're saying that the biggest angle is across from the longest side. Same exact concept. But they call them two different theorems, so I just wanted you to be aware that they do have a name. Opposite side angle theorem and opposite angle side theorem. So they do have a name. It doesn't, you don't, like I said, have to write it all down because you should have it on the other one. Now, if you look at this bottom triangle down here, I'm trying to move it up for you so you can see it a little better. If you look at this little triangle here, what side has to be the biggest? What side is the biggest? Has to be AB. Why does AB have to be the biggest side? Across from the biggest angle. Which one has to be the shortest? AC, because it's across from the smallest angle. Has to be the shortest. Okay, so that works for angles and it works for sides. If you've given sides, then you can tell which angle is the biggest. If they give you angles, then you can tell which side's the biggest. Just by looking at them, you can tell which one's the biggest. Okay, make a triangle with 3, 4, and 8 on your paper. So take your paper now, get a ruler, draw a triangle that has 3, 4, and 8. So 3, 4, and 8, you came to the conclusion that it's impossible. Here's what you could actually have on your paper, right? If you've got the 8, if you did that one first, and then you try to bring up a 4 and a 3, they won't touch. They won't get far enough because 3 plus 4 is how much? 7, not 8. You can never make 3 and 4 together make an 8. It's not going to happen, right? So what does that tell me about the shortest two sides of a triangle? They add up to the longest? More than the longest. Yes. So if you notice right here, 3 and 4 together would never reach 8. We do have a theorem. Okay, the theorem says this. Shortest two sides of a triangle will add up to more than the third side. More than, not equal to, it's got to be more than. That's why it's an inequality theorem. It adds up to more than the third side. So when I did 3 plus 4 and it was less than 8, it wouldn't make a triangle. What if the 3 was a 5? Is 5 plus 4 greater than 8? Then it would work. So it has to be the two smaller ones have to be bigger than the 8, or otherwise you can't make a triangle. So the shortest two sides of a triangle will add up to more than the third side. Is that better? Shortest two sides have to be greater than the third side. If not, you cannot make a triangle. Okay? That won't work. All right, how we looking? We just have a couple left. A couple left. Here's a couple of samples, a couple of practice ones. Which of the following side lengths form a triangle? Letter A, 5, 7, 8. Do they form a triangle? Okay, now on SchoolNet, when you put these in, you got to know why. Because I don't accept just yes. You're going to have to drag yes, and you're going to have to drag a reason. And what's the reason here? Because 5 plus 7 will add up to greater than 8. 12 is greater than 8, so yes, it's a triangle. 3, 9, and 5, does that make a triangle? I thought 3 plus 9 is more than 5. Oh, the two smaller sides. 3 plus 5 is less than 9, so yeah, it's no, not greater than 8 is not greater than 9, so it cannot work. So that one's definitely a no. Here's another example problem for you. Find the possible length of the third side of a triangle with sides of 6 and 11. The possible length of the third side? Let me give you some options. Could 7 be a third side? Yes, good. Could 3 be a third side? 3 cannot? Why not? Okay, so 3 plus 6 would add up to 9, and that wouldn't be greater than 11, huh? So 3 doesn't work. What about 4? No, that wouldn't. What about 5? 5 would equal 11. Would that work? No, it's got to be greater than 11. Now, do you remember what we did way back here on this first inequality right here? 2x had to be between 2 and 12 because we added the 5 and 7 and we subtracted the 5 and 7, right? What if we did that here on this one? 6 and 11. If I subtracted them, what would I get? 5. If I added them, what would I get? 17. My number's got to be somewhere between 5 and 17. Your third side. So if you add and subtract those two sides, your third side's got to be in the middle. So that would be that little theorem that tells us that. It says the third side of a triangle you can find by adding and subtracting the two sides that you have. Add and subtract the two sides and you can get your third side. It's got to be somewhere in that range. Okay, let's say that you own a sailboat and two of your sides are 6 and 8. That's your sail. The sail has a 6-foot side and an 8-foot side. What are the possible lengths for the third side of the sail? What could your third side of your sail be? 14 would not work. Got to be less than 14, right? And greater than what? 2. So it's got to be somewhere between 2 and 14. Remember, when I add and subtract, it gives me my range of numbers. It's got to be between those. It cannot equal that, otherwise it will not make a triangle. And the challenge down here at the bottom is to try to figure out how many triangles there are. Now, I accidentally left this up when you walked in. So some of you might already know the answer. I'm sure that some of you know the answer. I don't know how many of you do actually know the answer. But some of you do. So I already know that some of you do. But try it. See how many you can come up with, and I'll tell you your answer in a minute.